we can distinguish between a substance which might be a saturated compound versus a substance that might be an unsaturated compound doing a simple test. And that test is called the test for saturation. It is called the bromine test because we add bromine water to these two unknown substances, and the way it reacts with the bromine will tell us immediately if it is more reactive or less reactive, and therefore whether it be unsaturated or saturated. Here is a quick video just to show you how this test is performed.
The tube on the left contains the saturated hydrocarbon cyclohexane. The tube on the right contains the unsaturated hydrocarbon cyclohexene. First, brown-red bromine is added drop by drop to the left-hand tube containing saturated hydrocarbon. As the bromine is added, it dissolves in the cyclohexane. The color remains when the solution is stirred because bromine does not react with saturated hydrocarbon. Now, liquid bromine is added to the unsaturated hydrocarbon cyclohexene. The red-brown color disappears as the bromine mixes with the cyclohexene. This is because the bromine reacts with cyclohexene, adding to the double bond.
Let's have a look at the reactions in these two test tubes. If this is my saturated hydrocarbon and it reacts with bromine, it does not discolor, or it might discolor, but over a very long period of time. This is what the reaction would look like. If I take, for example, the saturated compound and I say that it contains 2 carbons, and each carbon are bonded to hydrogens, so that it fills to 4 bonds in total. Of course, it will have 3 hydrogens on this carbon and 3 hydrogens on that carbon. I add bromine water to it, which is diatomic, so it will have 2 bromine atoms bonded together, and then it will react over a very, very long time. But in order to react, actually, you will have to remove one of the hydrogens off of this compound. That takes a lot of energy and it requires a lot of time to actually substitute one hydrogen for another bromine to form this. I'm not going to draw the hydrogens, but we might say that this hydrogen will be replaced by one of these bromines, and then the other product will be HBr coming off. This might discolor, but over a long period of time. Bromine water is brown, and so it will eventually discolor if it goes and attaches itself onto the carbon chain. But this takes a long time to do. Well, if we have the same equivalent compound, like the 2 carbons with the hydrogens, but now you have a double bond, so it's unsaturated, double bond between the 2 carbons. Each of these carbons will have 2 hydrogens attached to it because it has a bonding possibility of 4. And so if I now add bromine water to it, maybe I should just change the color of this pen so it's a bit more visible. This is what will happen. You've got a strong sigma bond, which is your first covalent bond there between the 2 carbons, and then you have a weak pi bond as your second bond, forming the double bond between the 2 carbons. What will happen is that this weak pi bond will actually break, and now it will open sort of like a double gate, attaching or adding these 2 bromine atoms onto the carbon chain, like this. You have a bromine sitting there and a bromine sitting there, right? So this is brown initially, this whole solution, because of the bromine, but then it forms a colorless solution product, which will be my bromo unsaturated compound. This is how we test whether a substance is saturated or unsaturated. If it discolors very slowly or slightly, actually not at all, then it would be a saturated compound. But if it discolors, it goes from brown to colorless. If you add the bromine water really quickly, then we know it is indeed an unsaturated compound. And this is called the test for saturation.